All right, welcome to The Explainer. Today, we're going to jump into something really cool, probability. It's the math we use for things that only sometimes happen. In most of the math you learn in school, everything's certain, right? 1 plus 1 is always going to be 2, no surprises there. But the real world, it's messy, it's full of randomness. Take a simple coin toss. You have absolutely no way of knowing for sure if it's going to be heads or tails. It's just random. So, that leaves us with a pretty big question, doesn't it? How on earth can we use math, the language of logic and certainty, on stuff that's completely random and unpredictable? Okay, so let's dive into that. We're talking about the difference between certainty and chance. To even begin to measure all this randomness, we need a special kind of tool. And that tool, my friends, is called probability. So what is probability? Well, it's really just a number, a value that tells us exactly how likely something is to happen. So for that coin toss we were talking about, we can actually put a number on the chance of it landing on heads. And here's where it gets really visual and kind of cool. We can take all these different chances, from no way is that happening to it's definitely going to happen, and put them all on one simple line. Let's take a look. This is what we call the probability line, and it's super simple. It just runs from 0 all the way up to 1. Think about it. Something can't be less likely than impossible, and it can't be more likely than certain. So literally every single probability you can think of has a spot somewhere on this line. So let's start at the very beginning with the number 0. If something has a probability of 0, that means it's impossible. It's just not going to happen. No chance. Zilch. Okay, now let's go right to the middle. That's 0.5 or 1/2. This is your classic even chance. It means something is just as likely to happen as it is not to happen. And yep, you guessed it, this is our coin toss. Landing on heads is a perfect 50-50 shot. And all the way at the other end of our line is the number 1. A probability of 1 means something is absolutely certain. It's a done deal. It is 100% guaranteed to happen.
Oh, and just a quick heads up, you're going to see these probabilities written in a few different ways. Sometimes as a fraction, like 1/2, sometimes as a decimal, like 0.5, and sometimes as a percentage, like 50%. Just remember, they're all just different ways of saying the exact same thing.
All right, now we get to do some simple calculations. We've talked about coins, so let's move on to something a little more interesting, a standard 6-sided die. So here's a question for you. A standard die has 6 sides, right? So is the probability of rolling, say, a 3 also going to be 50%, like our coin flip? It seems like it could be, but actually, the number of possible outcomes changes everything. And here's the key thing to wrap your head around. That total probability of 1, that 100% certainty that something is going to happen, well, it has to be shared. It gets divided up equally among all the possible things that can happen. In this case, among all 6 sides of the die.
And this shows the difference perfectly. With the coin toss, you have a 1 in 2 shot, right? A 50% chance. But with the die, since there are 6 sides, your chance of rolling any single number is just 1 in 6. That's only about 16.7%. So yeah, way less likely than getting heads on a coin.
Okay, but what happens when more than one outcome is good for us? What if we're not just looking for one specific number, but a few different results could count as a win? Well, there's a really simple but super powerful formula for this. All you have to do is make a fraction. The number on top is the number of outcomes you want to happen. We call those favorable outcomes. And the number on the bottom, that's just the total number of things that could possibly happen. Let's try it with this spinner here. See? It has 16 sections in total. So if you want to land on blue, how many blue sections are there? 5. So that's 5 favorable outcomes. Your probability is 5 out of 16. And for yellow, well, there are 11 yellow sections, so your odds are much better, 11 out of 16. And check this out. This is a really important little trick. If you add up the probability of landing on blue, which is about 31%, and the probability of landing on yellow, about 69%, what do you get? 100%. It always works. The chances of all the possible things happening will always add up to 1. It's a great way to double check if you did your math right. Okay, so now we have to talk about theory versus reality. Because here's where things can get a little weird. The math tells us what should happen in an ideal world. But I mean, if you've ever played a board game, you know that reality doesn't always play by the rules, right?
Yeah, you know what I'm talking about. You can get these crazy streaks. You might roll a die 10 times and get a ton of twos and like 0 fives. And you're sitting there thinking, wait a minute, you said each number has the same chance. But look at this, the math must be wrong. And yeah, it can be super confusing.
But here's the thing. The math isn't wrong. Probability isn't about predicting the next roll. It's about what happens on average over a huge number of tries. In the short term, with just a few rolls, yeah, the results are going to be all over the place. But if you had the patience to roll that die 10,000 times, you'd see something amazing. The results for each number would get incredibly close to that perfect 1 in 6 probability we calculated. So let's wrap this up. I want to give you a quick recap, a little toolkit you can use to make sense of probability. Okay, here are the 4 big takeaways. Number 1, probability is always a number from 0 for impossible to 1 for certain. Number 2, the magic formula is just what you want divided by what's possible. Number 3, all the probabilities have to add up to 100% or 1. And number 4, and this is a big one, the more you do something, the closer your results will get to what the math predicts. So there you have it. You're now totally equipped to figure out the odds on pretty much anything. Which leaves us with one final big thought to chew on. Now you can calculate the odds, but does that mean you can actually predict the future?